Now, I've given you a whole bunch of functions that are defined by two different equations at two different places. And I will mention that this is by far, this particular pair of restrictions, x is negative and then x is positive, that's by far the most common one that you will meet. But it's not the only one, and you just have to look down the page to see the restrictions can be anywhere you want them to be. Okay, and you will get quite a different graph. So, let's have a look at this thing. You start, I tend to go from left to right. Okay, 1 minus x. Now, what does 1 minus x look like? I have an intercept at 1. Okay, and it's minus x, so it's increasing or decreasing? Decreasing, right? It's going down. It's going down. Okay. Now, this is only defined for x is less than 0. Okay, so what I've really got is this part of the graph. Okay, do you see that? So far, so good. Now, just like over here in this example, by the way, I tend to leave my endpoints until the end, right? That was not intentional. But anyway, I'll do my endpoints at the end. So I'm just going to leave that with no hollow or filled circle or anything. Okay. Now I've gone from the left, I'm going to move on to the right. So x squared plus 1, that's a parabola, and it's been shifted vertically up. So it also has, I should have labeled, it also has a y-intercept of 1. Right? This is nice and neat. Okay? So therefore, this is the shape that we're getting. Okay? Now when you have a look at this, okay, what you've got is this point, x equals 0, where it switches over. Okay, but because at the point of switchover, right, the y value of this and the y value of this, they match, they coincide, right? So even though it changes, it transitions, there are no discontinuities. Do you see that? There are no holes, right? Well, smoothly is maybe not the right word because it doesn't smoothly do this, but there's no break. There's no break. I can draw this whole thing and never lift up my pen, right? So there are no discontinuities on this graph. There is a change though, okay? Now, it's up to you, probably on the safe side, to put on, like, there is a point where it changes. So you can just, like, label that with a filled circle, because that's what it is. But because there are no discontinuities, I have no problem with it having no filled circle. You can just go from one to the other. Okay? There are two parts to this. So just like with absolute value, which by the way is another example of a piecemeal function, absolute value functions are by definition piecemeal. I'm going to label each of the branches, right? So I've got y equals 1 minus x, and y equals x squared plus 1. And I have my domains listed up. Okay. The question I asked to add on to this was, what's the range of this function? Domain's a bit boring. What's the range of this thing? Okay, yeah. Y can hit at 1, but it can't go any lower, right? So therefore, my range is y is greater than or equal to 1. If you want to include it for completeness sake, you can say that the domain is either all real x, but you're going to say that so many times you're going to get sick of it. So you can write the symbols if you like, an x, a curvy, funny looking e, it's actually an epsilon if you're curious, Greek, and then that double barreled r that I showed you before, which stands for real, right? So this means x is anything in the set of real numbers, right? All real values.